Swayam Prabha. Digital India. Educated India.
Welcome to the fourth lecture of the course Time Series Modeling and Forecasting. In this lecture, I will discuss different methods for the determination of trend component. In the last lecture, we have considered different graphical procedures for the presentation of time series, and then we have also discussed how you can use those graphical procedures or those graphs of the time series for checking which of the components are driving the variation in your time series. Means the variations in time series are whether due to the trend component or due to the seasonal component or due to the cyclical component or due to the mixture of some of these components. So, with the help of graph you can observe this kind of phenomena. Then for the determination of trend also we have discussed two procedures. One was based on the graphs of time series, the graphical method or the method of freehand curve fitting. Now, the method of freehand curve fitting gives you some idea of whether the time series has increasing trend or decreasing trend, or it has a linear or non-linear trend. So, you at least you get some idea of the trend component. Then we have also discussed the method of semi-averages, which is quite simple method. In that method, we just divide the observations into two parts and then we calculate the simple arithmetic mean of two parts, and using those arithmetic means you can draw the trend line, and you can also use that trend line for the determination of trend component. Even you can use that trend line for predicting the trend component. Now, one of the major problem with the method of semi averages is that it can be used only when the trend of the time series is linear. You cannot use that procedure when the time series is non-linear. So, that is why you require some other procedures for the determination of trend component. So, here we are going to discuss two procedures. One is the method of mathematical curve fitting for the determination of trend component, and the other method is the method of moving averages. Now, first we consider the method of mathematical curve fitting for the determination of trend component. So, suppose you have observations, n observations of the time series. So, we denote it as a bivariate data t by t, t equal to 1 to n. So, this is the given time series. And suppose Tt is the capital Tt is the trend value at time t, and we consider this trend value as a function of time t. So, you can write Tt as some function of time t. Then we try to establish a mathematical relationship between the trend and y t. Now, in the method of least squares, what we do? We fit the trend so that the sum of deviations is 0, means the deviation of y t from the trend component is given by y t minus t t. And if you take the summation of all these deviations, then this sum is 0. So, sometimes your observations are above the trend, sometimes your observations are below the trend, but overall sum of y t minus t t is 0. And the second condition is the sum of squares of deviations, means summation y t minus t t square is least. So, this is precisely the same method of least squares which we have discussed in our lecture 2. In lecture 2, we have considered the bivariate data of this form, say x t, y t, this is your bivariate data. Then we discussed how you can fit a curve between y t and x t, say suppose you want to fit a straight line, then y t is equal to beta 1 plus beta 2 x t plus other term. So, we use the method of least square. Here is equal to t. So, you get this kind of pair of observations t y t, but otherwise the method is precisely the same. We minimize the sum of squares of difference between y t and t t. Now, first we consider the simple function, say a straight line. So, this f t is equal to a plus b t. Of course, an other term u t is also there. So, we write t t equal to a plus b t plus u t. We assume that these u t's are identically independently distributed, and these u t's have say mean 0 and variance sigma square u. A and b are just like the regression coefficients. These are actually unknown parameters, unknown constants. These two are unknown. So, your problem is to estimate these parameters. So, here we replace t t by a plus b t. So, your conditions are the summation over t y t minus a minus b t is equal to 0, and the sum of squares summation over t y t minus a minus b t square is least, it is minimum. So, for determining the values of a and b, you have to minimize this term. Then for minimizing the sum of squares summation over t y t minus a minus b t square, what we do, we differentiate it with respect to a and with respect to b, and put these differential coefficients equal to 0, just like the method of least squares which we have considered for the bivariate data in the regression problem. Now, if you differentiate the first term with respect to a, then what you get? This term has power 2, so you get 2 here, summation over t y t minus a minus b t, and then we differentiate this part with respect to a. So, you get minus 1 here. So, we put minus sign here, this is equal to 0. Then we differentiate this equation, this summation with respect to b. Again, we obtain summation over t y t minus a minus b t 2 times, because the power of this term is 2, and then we differentiate this part minus b t with respect to b. So, you get minus sign here and then you get t here equal to 0. Then we simplify these two equations. You can take minus 2 towards this side. So, the first equation becomes summation y t equal to, now you are adding a n times t equal to 1 to n. So, you get n times a plus b into summation t equal to 1 to n t equal to, and then the second equation is you have summation over t y t into t. So, summation t y t, and the rest of the terms we are taking towards the right hand side. So, summation t y t equal to a plus summation a into summation t plus b into summation t square. So, you get these two equations. Obviously, what is summation t? Summation t is actually 1 plus 2 plus n. So, sum of first n integers. So, obviously, it is equal to n into n plus 1 by 2. Similarly, summation t square is equal to n into n plus 1 into 2 n plus 1 by 6. And for obtaining the values of a and b, you have to solve these two equations. These two equations are called the normal equations. You can easily solve these two equations and obtain these values of a and b. How can you solve these two equations? So, you multiply the first equation by summation t and you multiply the second equation by n, and then you subtract first equation from the second equation, and then you solve it, you get the value of b, and then from the first equation you can easily find the value of a in terms of b. So, a is equal to summation y t divided by n minus 1 by n b summation over t. So, ultimately you get this value of a, and then b is equal to this. In fact, you can write a equal to 1 upon n summation y t is equal to y bar, which is the mean of all the n observations. Minus b and 1 by n summation t is equal to, actually summation t is n into n plus 1 by 2, and you divide it by n. So, you get n plus 1 by 2. Similarly, you can find the value of b also. So, these are the least square estimators of a and b. Sometimes the computations become easier when you change the origin. For example, suppose you have odd number of observations. So, suppose n is equal to 2k plus 1. Then your middlemost observation is k plus 1th observation. Now, you transform sth observation by t equal to s minus k or the minus 1. Then the time series becomes t y t, and the range of t is from minus k to k. Then your normal equations are, now if you take this transformation, then your summation t, now its range is from minus k to k, this becomes 0. And so, the first equation becomes summation t equal to minus k to k y t equal to n times a, the second term vanishes. Now, from here you can easily obtain a equal to 1 by n and from the second equation you can easily obtain the value of b. b is equal to summation t y t upon summation t square. Range of t is from minus k to k. Now, if you take this kind of transformation and then you try to obtain the or predict the value of trend in the middle of the range, means at t equal to 0, then what is the value of t naught? Actually, t t is equal to a plus b t. So, for t equal to 0, it becomes a. So, your t naught is equal to summation y t upon n. So, basically what happens after this transformation? If you have odd number of observations and if you transform the time such that your midpoint is now your new origin, then the value of trend component at the midpoint is simply the arithmetic mean of observations from minus k to k. Let us take a simple example and we try to fit a straight line for this data set. We have data from years 2010 to 2018 and then the corresponding values of y's are also given here. So, in all you have 9 observations, n is equal to 9. So, the mid observation is the 5th observation, which is the 5th observation is 2014, this one. After this transformation, means you take year minus 2014 t equal to. So, corresponding to 2014 you have 0, corresponding to 2013 you have minus 1, then minus 2, minus 3, minus 4, and for years greater than 2014 you have 1 corresponding to 2015, 2 corresponding to 2016 and so on. Then you add all the t's, it becomes 0. You also require summation of y t. So, summation of y t means 10 plus 13 plus 13 plus 14 plus 15 plus 17 plus 20 plus 22 plus 21. So, ultimately you get 145. Then you can also calculate y t square. So, this column gives you yt square. You calculate t times yt. So, minus 4 into 10 you get minus 40, minus 3 into 13 minus 13 and so on. Then you add all these figures, you get 88. You can easily obtain t square also. So, then you need summation of t square. Now, you can easily obtain the values of a and b. What is a? A is equal to summation yt by n. So, summation yt by n is equal to 16.11. Then you can easily obtain the value of b also. After this transformation, the value of b becomes summation t yt upon summation t square. So, you take sum of this column, which is 88, divided by sum of this column, which is 60. So, b is equal to 1.47. So, your trend line is now T t is equal to 16.11 plus 1.47 into t. Now, how can you get these trend values? For year 2010, t is equal to minus 4. So, for 2010, t minus 4 is equal to 16.11 plus 1.47 into minus 4. Now, you can easily solve it. Ultimately, you get 10.23. Similarly, you can obtain other trend values also. You take t equal to minus 3, you get 11.7 and so on. So, once you fit the straight line, you can easily calculate the trend values corresponding to different time points. Now, once you have fitted the trend line, you can also calculate or obtain the predicted trend values corresponding to the years which are outside the range of the time series. Means, suppose you have to estimate the trend value corresponding to 2019. Now, since you have used this transformation t equal to year minus 2014, so what is the value of t? 2019 minus 2014, which is equal to 5. So, in this equation, you simply take t equal to 5 and then you can easily calculate the value of t t. Similarly, you can predict the trend values for 2020 or 2021 also. So, that is the main advantage of this method of mathematical curve fitting. Now, remember, this kind of manipulation or this kind of prediction of trend values is not possible with the method of freehand curve fitting, because you do not get any mathematical formula. Now, this is the fitted trend line for our data set. So, sometimes your observations are above the trend line, sometimes your observations are below the trend line, but if you add all these differences, then the sum of differences are 0. One more thing, in the method of least squares, just like what we have discussed in the earlier lecture 2, for bivariate data, we minimize the sum of squares of distances between observed values and corresponding trend values, and we take these distances parallel to the y axis. Again, the reason for taking the distances parallel to the y axis is that you are mainly interested in predicting the trend values corresponding to y's, the time series. So, your main focus is on the distances between the observed yt's and corresponding trend values. Corresponding trend values means you have to take distances parallel to the y axis. These are the methods of this method. It is free from personal bias. If 10 people are fitting a straight line, they all get the same result. Trend values for all the given time periods can be easily obtained. Then it also enables us to forecast the future values. You can easily forecast the future values, because you get a mathematical function, and just by substituting the value of t in the mathematical function in the straight line, you can easily forecast the trend values. There are some demerits of this method also. It is more computations are involved in this method in comparison to other methods, but nowadays it is not a big issue. You can easily do computations using any standard statistical software. Then addition of new observations always require recalculation. You have to recalculate the trend values or estimates of A and B whenever you get some additional observations. Then trend values for the distant future are not very reliable, because if you try to predict in distant future, then in between trend may change direction also. So, those values are not very reliable. Now, a generalization of a straight line is fitting of a polynomial. So, y1, y2, y is your observed time series, and we fit a polynomial of degree p for trend. So, your trend is represented by a polynomial of degree p plus ut. Again, just like the previous case of straight line fitting, we assume that UTs are identically independently distributed. Sometimes we also need this assumption of normality, but for using the method of least squares, you do not require this assumption, and these UTs have mean 0 and variance sigma square u. Then again, in the method of least squares, we obtain the values of beta naught hat, beta 1 hat, so on beta p hat by minimizing s equal to summation t equal to 1 to n y t minus beta naught hat, beta 1 minus beta 1 hat t minus so on minus beta hat p t to the power p whole square. So, what you have done, this is y t and this part is your t t. T t is a polynomial of degree p in t, and you have minimized the sum of squares of differences between y t and t t. Okay, so, in the method of least squares, we have to minimize this s, and for minimizing s, we just differentiate it with respect to say which is equal to, again you have a quadratic equation here. So, you get 2 and then we differentiate inside with respect to beta naught hat. So, you get -1 here. So, we put minus sign here and then we write it equal to 0. Similarly, we can differentiate h with respect to beta 1 hat. So, again you get -2 times summation y t minus beta naught hat minus and when we differentiate inside you get t here equal to 0 and so on. At last we differentiate with respect to beta p hat. So, you get -2 times summation y t minus beta naught hat minus beta 1 hat t minus 1 minus beta p hat t to the power p, and then when we differentiate inside you get t to the power p here, we put it equal to 0. So, this is how you get these equations, and then you can simplify these equations. So, ultimately you get these normal equations. To simplify these equations, you simply take -2 towards the right hand side. So, the first equation becomes summation y t, rest of the terms you take towards the right hand side. So, you get n times beta hat naught plus beta 1 hat summation t and so on. So, finally, you get these equations. These equations are called the normal equations, and for obtaining the values of beta naught hat, beta 1 hat, so on beta p hat, you have to solve these p equations. Sorry, actually p plus 1 equations are there. Now, we try to write down all these equations in matrix form. So, what we do? We form a vector with all these elements as components. So, you get a vector p plus 1 cross 1 vector, which has elements summation y t, summation t y t, so on summation t to the power p y t equal to, and in the right hand side you form a matrix which has elements n summation t, so on summation t to the power p and so on, and then you multiply it by the vector of beta components which has elements beta naught hat, beta 1 hat, so on beta p hat. Just to check, the first element summation y t is equal to n times beta naught hat plus beta 1 hat into summation t plus beta p hat into summation t to the power p. Now, this gives you the first equation. Similarly, if you take summation t by t, this is equal to, you take the second row of this matrix and multiply it by this column vector. You get the second equation, and so on. At last, you get the p plus 1th equation. So, you can write all the p plus 1 normal equations in this matrix form, and then for obtaining the values of betas, we take this matrix towards the other side. In fact, this is a non-singular matrix. So, you can take inverse of this matrix. So, this vector of betas, beta naught hat, beta 1 hat, so on, beta p hat is equal to the inverse of this matrix multiplied by this vector. So, this is how you can obtain the least square estimators of the parameters beta naught, beta 1, so on, beta p. Now, once you estimate these parameters, you can easily obtain the trend equation. You can easily estimate the trend equation. Just to further simplify the things, we introduce more notations. We write y equal to y 1, y 2, y n, beta equal to beta naught, beta 1, so on, beta p, transpose. So, this is n cross 1 vector, this is p plus 1 cross 1 vector, beta hat is the vector formed by corresponding least square estimators. So, this is also a p plus 1 cross 1 vector, and x t transpose is a p plus 1 cross 1 vector with elements t, t square, so on, t to the power p. Then we write x matrix as its first row is equal to x 1 transpose, second row is x 2 transpose, so on, and nth row is x n transpose. So, this is n cross p plus 1 matrix X, and C is the matrix formed by different sum of squares of T. First element is n, 1/2th element is summation T, 2/2th element is summation T square, and so on. In fact, you can easily verify that its ijth element is equal to summation T to the power I plus j minus 2. Then using these matrix notations, you can easily write the set of normal equations full, which just to remind you, I have again written here. This is the set of equations full. So, you can write this set of equations as beta hat equal to, now this is your C matrix. So, beta hat is equal to C inverse, and this is actually x transpose y. Suppose you write delta T transpose equal to x T transpose in x inverse x transpose. Then your estimated trend values are, so T T is equal to beta naught hat, beta 1 hat T, so on, beta P hat T to the power P. You can write this as x t transpose beta hat. Remember in lecture 2, we have derived the least square estimator for the multiple linear regression model, and that estimator was so we are using the same formula. So, beta hat is equal to x transpose x inverse x transpose y. So, you can write it as x t transpose x inverse x transpose y, and then we write this entire vector as delta t transpose. So, T t is equal to delta t transpose y, this value is your estimated trend value. Now, my purpose for doing all this exercise is that your estimated trend value is a linear function of y. So, I wanted to show you that your estimated trend is a linear function of y. Of course, this method is totally objective. For the fixed value of p, if 10 people are fitting a polynomial, they all will get the same result, provided they are using the same method. But the problem with this method is that if we fit a polynomial of very high degree, then the estimates involve higher moments, which are very sensitive to small sampling fluctuations and are not very efficient. Sensitive to small sampling fluctuations means if you get small changes in data, the estimates are quite different. So, the estimates are very sensitive to small changes in data, which is not a good sign. Then changing the power of fitted polynomial to higher one requires recalculations, but you can overcome this problem by fitting an orthogonal polynomial. The next method is the method of moving averages. Now, suppose a time series has n observations y 1, y 2, y n. The moving average in order m, which is equal to 2 k plus 1, is defined as T t equal to 1 upon m. We take summation j equal to minus k to k y t plus j, t equal to k plus 1, k plus 2, so on up to n minus k. Now, this gives you the estimate of trend at time t, and this moving average is called the m moving average, that is a moving average of order m. So, basically what we have done, we have time series y 1, y 2, we go up to y 2 k plus 1, y 2 k plus 2, so on. So, first we calculate the average of these 2 k plus 1 observations. We write it equal to, now this gives you the trend value corresponding to the middle point, means corresponding to k plus 1. Your midpoint is k plus 1. So, you get T k plus 1. Next time you leave the first observation y 1, you start from y 2, and then you go up to y 2 k plus 2. You take simple arithmetic mean, you get t k plus 2 and so on. And you continue this process until you reach the last 2k plus 1 observations. Now, remember when we fitted a straight line for m equal to 2k plus 1 observations, and say if we change the origin so that your new origin is in the middle of the range, then the estimated trend value in the middle of the range was simply the arithmetic mean of 2k plus 1 observations. Same argument we are applying here also. Your trend value is summation t equal to minus k to k y t upon 2k plus 1. This is the trend value corresponding to the observation in the middle of the range. Now, average eliminates the randomness in the data, and then it leads to a smooth trend component. So, this is the argument behind using this method. You can also take moving average of moving averages. So, first you apply m terms moving average, and then you get a series of moving averages. Then you can again apply a r term moving average. So, you have series y t, you get m terms moving average, and to this series we apply say r terms moving average. So, this gives you r cross n m moving average. So, these are the steps of the method of moving averages. First, you obtain the means of first term successive observations, write the moving average against the midpoint m plus 1 by 2th point, leave the first observation, include the number m plus 1th observation, and find the mean again. So, you get the observations y 2, y 3, so on y m plus 1, write the moving average corresponding to the midpoint m plus 1 by 2 plus 1th observation, and you proceed like this. Now, if m is equal to 2k means m is an even number, then your moving average will not correspond to an observed time point. Then what you can do, you further take a 2-term moving average. Now, this makes the trend component T t corresponding to the observed t, because the midpoint of even number of, if you have 4 observations, you are taking moving average of 4 observations or 4 terms, then it will correspond to 0.2.5. Now, for t equal to 2.5, you have not taken any observation. If you further take 2-term moving average, then you get a moving average corresponding to the observed value of t. Now, these are the methods of this procedure. It can be used for measuring the trend of any series. It is applicable to linear as well as non-linear trends, but there are some demerits also. Trend values are unavailable corresponding to the first few and last few observations. Then trend obtained cannot be extended for forecasting future values. Remember, you do not get any trend values corresponding to last few observations. So, it becomes difficult for you to calculate the trend values corresponding to last observations. It is not applicable to short time series because you are missing several trend values. The method is objective for fixed moving average period, but selection of the period of moving average is subjective. This is another problem. Briefly, I will discuss this example. This is the time series data. So, you can calculate 4-year moving average as well as 5-year moving average for this data set. So, for 4-year moving average, the procedure is very simple. First, you take the observations 140 to 166. You add all these observations, divide it by 4, you get the value 155. You leave 140, start from 151, go up to 172 and so on. And then since these values are not corresponding to the observed time points, you further take a moving average of period 2. So, finally, you get values which are corresponding to the observed time points. Similarly, you can take 5 period moving average also. Here you have first you have started from the first observation, you went up to the 5th observation. You take average of these 5 observations. You start from here, you go up to this point. You take the average and then write here and so on. But notice that you are missing the trend values corresponding to first 2 and last 2 observed time points. These last 2 time points are very important, at least for prediction purpose, because for prediction you require more recent trend values. More recent trend values are more important. So, this is the main drawback of this method. You do not get trend values corresponding to last few observations. So, today we have discussed 2 methods for determining the trend component, the method of mathematical curve fitting and the method of moving averages. These methods provide you explicit formula for calculating the trend component, at least the method of mathematical curve fitting can be easily used for obtaining the trend values corresponding to the future time points. In the next lecture, I will come back to the seasonal component. We will consider different graphical procedures for the determination of seasonal component, and then we will also consider different methods for obtaining the exact seasonal indices. So, thank you.
I am A.K. Sharma and I teach sociology at IIT Kanpur. I am going to address the question, what is the relevance of statistics in sociology? In India, there is some confusion about role of statistics in sociology, and most of the students of sociology suffer from what I call phobia of statistics. But actually, if you look at history of sociology or the kind of works that are being done in sociology, which are published in prestigious academic journals, you find that there is a lot of use of statistical methods, and not simple methods, very advanced methods. all of you know, as students of sociology, you know that one of the founding fathers of sociology, Comte, or another founding father, Emile Durkheim, they said that sociology is one subject which differs from other subjects in the questions that they try to answer, but they use the same method, the method of science. And that in sociology, those who believe in this kind of approach, they are called positivists. Emile Durkheim called them positivists. They believe that social issues must be studied by using observations, experiments, and other modes of collection of data. Now, statistics can help sociologists in three ways. Because if sociology is about social facts or patterns, not individuals, patterns of thinking, patterns of feeling, patterns of acting, behaving, and they can be measured, they can be quantified, and that explanation of one social fact can be given only in terms of other facts. We need statistics, because statistics can measure these facts. Statistics can describe these facts. So, one branch of statistics, we can call it descriptive statistics, can help us in summarizing data, in measuring facts, like you are all familiar with simple statistical things like mean, mode, median, or methods of dispersion, standard deviation, range, variance. These are descriptive measures. They can also be used to measure skewness or symmetry or asymmetry in the data. Other types of statistical methods, which are called inferential statistics, are used to test hypotheses. We know that any science, including sociology, if we follow that positivistic tradition, is about testing hypotheses using scientific methods. And for testing hypotheses, like for comparative purposes, comparing means of two samples, or comparing variances of two samples, or comparing correlation coefficients or regression coefficients, we need inferential statistics. And if you are familiar with some of them, t-test, z-test, chi-square test, f-test, these are the tests which come under inferential statistics. We use statistics for drawing inferences about two or more samples. And thirdly, statistics can also be used for posing new questions. I remember that a few months ago, I read an article in Population and Development Review in which the authors, Cole and Gramajo, they tried to explain homicide rates and variations in homicide rates across countries in the entire world. And they found, based on statistical analysis, logistic regression and all, they found that one factor which explains variations in homicide rates in the world is female education. Not culture, not governance so much, not even male education, but female education. Now, if facts are showing this, so you have a new sociological question: why is it that rise in female education leads to higher homicide rates? And Cole and Gramajo then gave certain hypotheses. You may not agree with those hypotheses. You may conduct this study on your own or test these hypotheses given by Cole and Gramajo using statistical methods. But the point I am making, that in addition to describing data, drawing inferences, statistical methods can also be used for raising new questions in sociology. And of course, you are all familiar that whenever the issue of prediction comes, predicting population of India, predicting urbanization, predicting per capita income of India 20 years from now, 50 years from now, there also statistical methods are of great help. And finally, statistical methods have been used in monitoring and evaluation of development policies run by various governments and NGOs. Thank you very much.